Ships are the workhorses of the global economy. They are the silent giants that traverse the oceans, ensuring that the wheels of commerce keep turning. Without them, the global supply chain would come to a grinding halt. They haul everything from bananas to bulldozers, from electronics to everyday essentials. These vessels are the backbone of international trade, moving goods across continents and connecting markets. But all that hauling comes at a cost: pollution. The environmental footprint of these massive ships is significant and often overlooked. Ship engines, like any engine, spew out nasty stuff. These engines burn heavy fuel oil, which is one of the dirtiest fuels available. We're talking sulfur oxides, nitrogen oxides, particulate matter, the works. These pollutants are harmful not just to the environment but also to human health. These pollutants don't just disappear, they linger in the atmosphere, contributing to a range of environmental issues. They contribute to acid rain, smog, and respiratory problems. Acid rain can damage crops, forests, and aquatic ecosystems, while smog can cause serious health issues for people living in coastal areas. Not good for us, not good for the planet. The impact of ship emissions is far-reaching, affecting both urban and rural communities. Remember those hazy days when you could barely see across the harbor? That thick layer of smog is partly due to ship emissions. Yeah, ships play a role in that. The emissions from these vessels contribute significantly to air pollution in port cities. And it's not just the air we breathe. The pollutants from ships also settle into the water, affecting marine ecosystems. The ocean takes a hit too. Coral reefs, which are vital to marine biodiversity, are particularly vulnerable to pollution. Polluted air can lead to ocean acidification, harming marine life. Acidification affects the ability of marine organisms to build shells and skeletons, disrupting the entire marine food web. So what can be done? The shipping industry is aware of these issues and is taking steps to mitigate its environmental impact. Well, that's where exhaust scrubber systems come in. These systems are designed to remove harmful pollutants from ship emissions before they are released into the atmosphere. They're like giant air filters for ships, helping to clean up their act. By installing these scrubbers, ships can significantly reduce their emissions, making the air and water cleaner for everyone. Imagine a shower head for your car's exhaust pipe, only a whole lot bigger, and instead of water, it uses a special chemical spray. That's the basic idea behind an exhaust scrubber system. These systems are designed to remove harmful pollutants from ship exhaust gases before they're released into the atmosphere. They act like giant air purifiers, helping ships meet increasingly stringent environmental regulations. Think of it as giving those big diesel engines a much-needed bath, leaving the air and water a little cleaner in the process. Let's get down to the nitty-gritty. Ship engines, particularly the massive diesel engines powering most cargo ships, are the culprits behind those dirty exhaust fumes. These engines burn heavy fuel oil, a thick, sludgy fuel that's cheap but dirty. The combustion process, while essential for generating power, produces a cocktail of unwanted byproducts. We're talking sulfur oxides, which contribute to acid rain, nitrogen oxides, a key ingredient in smog, and particulate matter, those tiny particles that can wreak havoc on our lungs. It's a recipe for environmental disaster. Now let's pop the hood on a scrubber system and see what's inside. First, you've got the scrubber tower itself, a large cylindrical structure installed in the ship's exhaust stack. Inside the tower is where the magic happens. Spray nozzles line the tower's interior, showering the incoming exhaust gas with a fine mist of seawater or a specially formulated chemical solution. This spray is key to capturing those nasty pollutants. But there's more. The tower also contains packing material, which provides a large surface area for the chemical reactions to take place. Section 5, the scrub down, how it actually works. Picture this. Hot, dirty exhaust gas enters the scrubber tower, loaded with pollutants. These pollutants include sulfur oxides, nitrogen oxides, and particulate matter, all of which are harmful to the environment and human health. As the gas rises through the tower, it collides with the downward spray of seawater or chemical solution. This interaction is crucial because it initiates the process of removing the harmful substances from the exhaust gas. This is where the scrubbing action begins. The downward spray creates a turbulent environment, ensuring that the exhaust gas thoroughly mixes with the scrubbing solution. The pollutants, particularly sulfur oxides, react with the spray and are neutralized. This chemical reaction transforms the harmful sulfur oxides into less harmful substances, such as sulfates, which can be safely disposed of. The seawater or chemical solution acts like a magnet, attracting and capturing the pollutants, preventing them from escaping into the atmosphere. This process is highly efficient, capturing up to 90% of the sulfur oxides and other pollutants. The now cleaned exhaust gas, stripped of most of its harmful components, exits the scrubber and is released into the air. This significantly reduces the environmental impact of the ship's emissions, contributing to cleaner air and a healthier planet. Section 6. Scrubbers and action-proof in the plume, or lack thereof. You can actually see the difference a scrubber makes. These devices are designed to clean the exhaust gases emitted by ships, and the results are quite visible. Stand near a ship without a scrubber, and you'll likely see a thick plume of dark smoke billowing from its funnel. This smoke is filled with harmful pollutants, including sulfur oxides, which contribute to air pollution and acid rain. Now, be significantly fainter, almost invisible in some cases. This is because the scrubber has removed most of the harmful substances, leaving behind cleaner exhaust gases. That's visual proof that the scrubber is doing its job, removing pollutants and releasing cleaner exhaust gas. The technology behind scrubbers is quite advanced, involving multiple stages of filtration and chemical reactions. But don't just take our word for it. Researchers and scientists have been studying the effectiveness of scrubbers for years. Independent studies have confirmed that scrubbers can remove over 90% of sulfur oxides from ship exhaust, a significant reduction in harmful emissions. These studies involve rigorous testing and data analysis to ensure accuracy. The data is clear. Ships equipped with scrubbers emit far fewer pollutants than those without. This not only helps in reducing air pollution, but also complies with international regulations aimed at protecting the environment. As more ships adopt this technology, we can expect to see cleaner skies and healthier oceans. The maritime industry is taking significant steps towards sustainability, and scrubbers are a crucial part of this journey. Installing a scrubber system is a complex process, requiring careful planning and engineering. However, the benefits far outweigh the challenges, making it a worthwhile investment for the future of our planet. In conclusion, the proof is in the plume, or the lack thereof. Scrubbers are making a tangible difference in reducing ship emissions, contributing to a cleaner, healthier environment for all. Section 7. ECAs, where clean air matters most. In certain parts of the world, the need to reduce ship emissions is even more critical. These are known as Emission Control Areas, or ECAs. These areas, often located near coastlines or in heavily trafficked shipping lanes, have stricter limits on air pollution from ships. Scrubbers play a crucial role in helping ships comply with these stricter regulations. By significantly reducing sulfur emissions, scrubbers allow ships to operate within ECAs while minimizing their environmental impact. It's all about protecting air quality and human health in these sensitive areas. Section 8. Keeping scrubbers ship-shape. Maintenance matters. Like any piece of complex machinery, exhaust scrubber systems require regular maintenance to ensure they're operating at peak efficiency. Think of it like changing the oil in your car. Neglect it, and you're headed for trouble. Regular inspections, cleaning, and replacement of worn parts are essential. The spray nozzles, for example, can become clogged over time, reducing the scrubber's effectiveness. Proper maintenance ensures that the system continues to capture pollutants effectively, keeping our air and water clean. Section 9. Open loop, closed loop, hybrid the scrubber lineup. Now, not all scrubbers are created equal. There are different types, each with its own pros and cons. Open loop scrubbers are the most common. They use seawater as the scrubbing medium, taking in water from the ocean, using it to clean the exhaust gas, and then discharging the treated water back into the sea. Closed loop scrubbers, on the other hand, use a recirculating loop of chemical solution, treating and reusing the solution multiple times before disposal. Hybrid systems combine elements of both, offering flexibility depending on the operating conditions. Section 10. A cleaner horizon scrubbers and the future of shipping. As we look to the future, the shipping industry faces the challenge of reducing its environmental footprint. Exhaust scrubber systems are a vital tool in this effort, helping to clean up ship emissions and mitigate their impact on our planet. While scrubbers are not a silver bullet solution, they represent a significant step towards cleaner shipping. As technology advances, we can expect to see even more efficient and effective scrubber systems, further reducing the environmental impact of this vital industry and ensuring a healthier planet for all.